A very good morning to my lecturers, Dr. Corbin Shaw and Dr. Eng Mei Feng. My name is Joanne Tan Jia. I'm from class MTE1. Today I want to present about my task 3, which is application of linear programming in daily life. This table content shows the number of slides and pages for each title, including introduction, application of algebra in daily life, model of linear programming, solving the linear programming with model, which includes identifying the variable, identifying the objective function, identifying the constraints, and solving the problem by using graphical method, and the last one, conclusion. First and foremost is the introduction of linear programming. Linear programming is a mathematical method which is used to determine and planning for the best possible outcome from a given set of which are represented in the form of linear relationships. It mostly be used to find the maximum or minimum of profit, cost, people, time, and many more. The maximization or minimization is the objective of linear programming problems. All linear programming problems have constraints that limit the degree to which the objective can be pursued. Linear constraints are linear functions that are restricted to be less than or equal to, greater than or equal to, less than, or more than constant. A graphical solution method can be used to solve the linear programming with two problems. In most cases, the best outcome needed from linear programming is maximum profit and the lowest cost. Therefore, linear programming models can be used to help select optimal media mix. Media selection can be approached with linear programming from two perspectives, either to maximize audience exposure or minimize advertising costs. Application of algebra in daily life. Here is the example of question in linear programming in daily life. The question is, Mr. Lee is a florist. He has a big garden at the back of his house. He usually plants some beautiful flowers in his garden and sells them in the shop. He is planning to plant some sunflowers and some roses in his garden. He wants to plant at least 30 flowers in his garden. The number of roses should not of sunflowers. He estimates to spend about 100 ringgit to plant the flowers. Each sunflower seed costs 1 ringgit while each rose seed costs 2 ringgit. When the flowers grow up, one sunflower can be sold at 3 ringgit while one rose can be sold at 5 ringgit. Mr. Lee wished to determine the number of sunflowers and roses that should be planted that will maximize the profit. 3.0 Model of linear programming. Model of linear programming includes some steps. Step 1. Identify the variables. Step 2. Identify the objective function. Step 3. Identify the constraints. Step 4. Solving the problem by using graphical method. Then we need to solve the linear programming with the model they are given just now. First, we should identify the variable. The variable usually we use is S1 and S2. In this question, S1 represents the number of sunflowers to be planted, S2 represents number of roses to be planted. Then we need to identify the objective function. In this question, we are asked to find the number of sunflowers and roses to maximize the profit. To find the maximum profit, 3 ringgit of sunflowers minus the original cost of sunflower, which is 1 ringgit. and plus 5 ringgit minus 2 ringgit, which is the original cost of roses. Thus, the objective function is z equal to 2s1 plus 3s2 to find the maximum profit. Our objective function is this question. Thirdly, 4.3. Identifying the constraint. In the question, we know that Mr. Lee wants to plant at least 30 flowers. So the first constraint is S1 plus S2 greater than or equal to 30. Then the number of roses should be more than twice the number of sunflowers. So the second constraint is S2 greater than or equal to 2S1. Because the number of roses should not less than number of sunflowers. That means also can equal to the number of sunflowers. Next, Mr. Lee estimates to spend about 100 ringgit to plant the flowers. The information we get is one sunflower costs 1 ringgit once, one rose costs 2 ringgit. So the third constant is S1 plus 2S2 less than or equal to 100. In the question, Mr. Lee wants to plant both sunflower and roses. So both of them should not equal to 0. So the constraint is S1 or S2 should be greater than 0. That means at least one sunflower or at least one rose to be planted. Then we should solve the problem by using graphical method. By plotting the graph, we need to find the coordinate and draw the straight lines so that we can find the region and shape the region we will need. For the first constraint, S1 plus S2 greater than or equal to 30. So when S1 equal to 0, S2 equal to 30. When S1 equal to 30, S2 equal to 0. Next, for the second constraint, S2 greater than or equal to 2S1. So when S1 equal to 0, S2 also equal to 0. So 0, 0 is the first container we get for the second constraint. Then when S1 equal to 20, S2 equal to 40. So the second coordinate we get from the second constraint is 20, 40. The third constraint we get is S1 plus 2S2 less than or equal to 100. So when S1 equal to 0, S2 equal to 50. This 0, 50 is our first coordinate we get. When S1 equal to 40, S2 equal to 30. This is 40, 30 is our second coordinate we get for this constraint. So we need to find this coordinates to plot the graph, plot the line, and find the region. Here is a graph that shows the region that defines all solution space of the model. This line shows the third constraint, which is S1 plus 2S2 equal to 100. This line shows the first constraint, which is S1 plus S2 equal to 30. This line shows the second constraint, which is S2 equal to 2S1. For plotting the graph, the sign greater than or less than should be changed to equal to. So for the first constraint, S1 plus S2 greater than or equal to 30, so the region should be in here. Then for the second constraint, S2 should be greater than or equal to 2S1, so the region should be here. or here. For the third constant, S1 plus 2S2 should be less than or equal to 100, so the region should be here, here or here. Then S1 and S2 should be greater than 0, so the number is positive, so the region is here. Lastly, we should find the maximum profit for the equation here. This is the objective function. Here I put 30 at the back of this equation. So for the objective function, each number should be divided by 30 because I put 30 here. The coordinate we get is 15 and 10 after divided by 30. Thus, we should plot that 15 and 10. Then we should move out straightly and reach this point, which is the maximum. The maximum point is here, so this is the maximum profit which we will get. And this is the maximum number of S1, which is sunflower we should plant, and this 40 is the number of S2, which is roses we should plant. The answer we get is 20 and 40. So 2 times 20 plus 3 times 40 equal to our maximum profit. So our maximum profit found is 160 ringgit. So at the end, the answer is 20 sunflowers and 40 roses to be planted. And the maximum profit we found is 160 ringgit. This is the answer of this question. In conclusion, linear programming can be used to solve the problems in daily life. For example, linear programming is used to help Mr. Lee to determine the quantity of sunflower and rose needed to plant to maximize his profits. As first, identify the variable. Then we should identify the objective function, which is to maximize the profit. Next, we should identify the constraint with need to plot the graph. After plotting the graph, we should determine the optimum solution from among all the corner of extreme points in the feasible region. Hence, to maximize the profits, 20 sunflowers and 40 roses should be planted. And the maximum profit we found is 160 ringgit. So by using the formula and the model given, we can find the answer. So linear programming is used to find this maximum profit. That's all for my presentation. Thank you.